All right, tonight we're going to do antiderivatives. So what we first did were derivatives. So if I have some function f of x equals 3x squared plus 7x plus 5, and I wanted to find the derivative of that, I would say f prime of x or y prime. So that means the derivative. And with this, we're going to use the power rule. So the power rule says you do 2 times 3. 2 times 3, that's 6, x, and then you subtract 1 from the exponent. When I subtract 1 from the exponent, that gives me x to the first. Then the derivative of 7x, after so many times of doing it, we figured out it was just 7. And then the derivative of 5, it goes away. So technically, it's plus 0.
So now what we want to do is we're given this, and we want to write the original. And the way to say to get back to the original is to put this antiderivative symbol in front of it. So the antiderivative of the derivative equals f of x. So I want to do this. I want to find the antiderivative of 6x plus 7 plus 0. And usually we say with respect to x. Now, to do the antiderivative, my answer should look something like this. What I do is instead of subtracting 1 from the exponent, I add 1. So what's 1 plus 1? That's going to give me x squared. And then I have the 6x squared. Instead of multiplying by the coefficient and the exponent, I divide by the exponent. So I would divide by 2. Now, the antiderivative of 7x, the derivative of 7x is 7, so the antiderivative of 7 is 7x. It just works backwards. And now this is a little strange. The antiderivative of 0, it can be any number whatsoever. It can be 0. But notice, in this case, it was 5 originally. But we don't know what it's going to go back to. So any number, and we're going to simplify this. So our answer is f of x equals 6 divided by 2 is 3, x squared plus 7x. And instead of writing this long any number notation, we'll just say plus some constant c, where c is any number. C equals any number. And that's an antiderivative. So I want to find the antiderivative of 7x squared plus 5x plus 3 plus 0. Now I know that 0 is going to turn into c. I know that 3 is going to turn into 3x. And then I have to do the calculus maneuvers with these two terms. So I'm going to add 1 to that exponent. So that's going to give me 7x cubed. And then I divide by the exponent. So 7x cubed over 3 plus, that's a 1, a hidden 1 up there. I add 1 to that exponent. So that's going to generate 5x squared. And then I divide by that exponent of 2. The antiderivative of 3 is 3x. And then the antiderivative of 0 is plus c. And there's the answer. Try another example. I want to find the antiderivative of 5x cubed plus 2x squared minus 4. Notice I'm not putting the plus 0 over here. I forgot to put the dx at the end of this. That's just manners, we'll say. That's proper notation. That means with respect to the x-axis. So I'm going to take the antiderivative. I'm going to add 1 to the 3 to the exponent. That's going to give me 5x to the 4th. Then I divide by 4 plus 2x. I add 1 to the 2, so that's going to give me 3 over 3. The antiderivative of 4 is 4x plus some constant c. 7x to the 5th plus 3x to the 4th minus 2x plus 9. With respect to the x-axis, add 1 to the 5, it's going to give me 7x to the 6th over 6. Add 1 to the 4 plus 3x to the 5th over 5. Divide by that exponent. Minus 2x to the 2nd divided by 2. These 2's will simplify. That will just simplify to just x squared. Plus 9x plus c. When you do these, there should always be a c at the end of it. I'm going to simplify it. This is the only one I can simplify, is the 2x squared over 2. So it's going to be 7/6 x to the 6th. Either way is a correct representation of it. Plus 3/5 x to the 5th minus x squared plus 9x plus c. So here's some derivative examples. If I had f of x equals e to the x, well, the derivative would equal e to the x. So the antiderivative of e to the x with respect to the x-axis is also e to the x. It goes backwards. Another example, if f of x equals ln x, the derivative f prime of x equals 1 over x. So if I want to know what the antiderivative of 1 over x dx is, that's just going to equal ln x. Now I made a mistake in both of these examples. I forget to come back and put the plus c. I have to come back and put the plus c. Some textbooks make you put absolute value bars around the x because you're not allowed to take the natural log of a 0 or a negative number. So it's kind of tricky.